Alright, continuing OS dev here. I want to get rid of int 13h as we currently have it for loading and writing stuff to the disk. I want to replace it with ATA ports, or specifically the ATA PIO, I think is programmed IO. That's what that stands for, the ATA PIO ports. So I have a small example for that I'll show in a bit, but before I do that, I kind of want to consolidate some file loading logic first, since we have the load file, include file. I still wanted to find where we're not using that, so the boot sector, I'm probably not going to call load file. I'll keep the boot sector as its own thing, but the kernel, we can probably replace these int 13h lines with calls to load file that we already have. So kind of consolidate logic there, so that way I only have to replace stuff in one file, the file ops include file, instead of maybe 3 or 4 places. So the kernel and the print file table, I'll try to refactor it here and make calls to load file, so we'll see how that works. I'll open both of them, I guess. We'll look at the kernel and we'll look at this. Okay, so if I can spell load file, here we go. But the params are just file name and then memory segment to load to, memory offset to load to. Okay, and the kernel int 13h is under found program, this label. I may want to try and replace all of this, like the check files stuff, but the only thing I'm wary about is the file extension. So we're getting if it's text or bin, and I'm not passing that back from any of these functions in our file ops include file, so I might have to keep the code here just for that. But as far as actually loading the thing, I can probably replace int 13h with a call to load file, assuming we don't get any errors or anything. I don't think I'm returning an error code in load file. I'm not, so hopefully it doesn't mess anything up, but I'm gonna return an error code because I'm not doing that yet and I'm setting aside space for it anyway. So let's just go ahead and do that. We'll move that into AX. We'll put that in AX. So let's assume it's 0, so there's not an error. So reset. So what I'm going to do is, for my limited testing using the ATA PIO ports, I didn't really need to care about resetting the disk. I didn't try that at all, so I don't know if we need to do that, but I'm going to take that out and hope it works okay. I'm just going to worry about actually loading the sectors here. So with this stuff, so instead of this stuff, I'm going to call load file. So the file name that I want to load, though, how do I know what I want to load? I guess the user entered it in at this point, right? So it's command string. That should be the name of the file that we're checking. Okay. So I'll push, does it need to be an address? Sorry. I don't remember these things. File name. So I put here address. Let me change this comment here because this isn't immediately apparent. So let's change that. Do what I did for the other one. For the other ones, I'll do input 1 will be file name, address. Input 2 is going to be memory segment to load data to. Input 2 rather. Input 3 is going to be memory offset to load data to. Okay. Have that as a buffer line. All right, so that way I can go, okay, I'll push the file name first, and then the segment, and then the offset. So we're gonna load programs, or I guess text files in the kernel is what we've been doing as well. Yeah, we're loading to 800 offset 0 or 8000. So okay, let's push word, it's an address, so we'll push command string. So the offset we want to go to is 800. Or we can push 0 and 8000. So we'll call load file. And then SP 3 words is 6 bytes. So I'll do that to clean up the stack. And hope we don't have to do this anymore. That reads it to memory. That's the drive number. So we do need to pass the drive number, however. I'll just copy that, move it up here. Okay, and after we call it, let's check the return code, which is AX. So if it's 0, then we'll go to run program. So I'll do equal. There we go. If it's not 0, then we can do the program not loaded message. So that'll be all right. It's a text file. So this stuff should be all right. I don't like having, you know, file search logic all the way up here as well. But at the moment, I think we'll have to keep that. I don't think we'll have to do this stuff though. We just need to save the extension. I don't really need to save this other thing here. After file size, okay. Because we should handle all of that within load file, right? Get the params off the stack. First one is going to be the highest address, and then segment offset's going to be the last one. Yeah, okay. Okay, found file. We're getting the file type. So we could pass it back. Otherwise we handle errors. I do have the file type though. Return file type in BX. So I am passing the file type back. Interesting. So that's in BX. Well, the address is. Do I use that in the editor? I should remember this. Let's see if I have call load file. Yes. So do I use that? Oh, I do. Yeah, I do right here. Interesting. Okay. Go to editor depending on type. Okay, well I could do that within the kernel then. Then I would not need to do this extension stuff here. So it's passed back in BX. Okay. Okay, if we go to run program, go here. File extension or type, however you want to say, is returned in BX from call to load file. Okay. I guess I can do like what I did in the editor then. What buffer is that? 3? Okay. Moved it to A and then I stored. Yeah, I'm going to do that here. Assuming DI is set up, which it should be, hopefully. Veil BX, store SB. And we'll do BX plus 1 and plus 2. Okay, so that should get the extension there, hopefully. Similarly enough. So that way I don't have to get it up here. I'm going to erase this code once I'm sure that stuff is working. We do check if it exists within load file over here after we call check file name. So if it doesn't, we'll have an error if it's not found. So I could even get rid of this stuff in the kernel as well. Or everything will break, you know, I mean that's likely as well, but let's just assume we're gonna be okay, because this stuff is already being checked in load file. I don't like duplicating logic if we don't have to, so. Opcx, we'll go down here. So, call load file function to load to memory address 8000. Load program or file. Return values AX. I'll do this. Return values from load file. AX will be return / error code 0 equals success, not 0 equals error. And BX will be file type / extension. I like putting slashes for either or, but I do that a lot. If that's ever confusing, let me know. That's just something I'm used to doing for like years now. So file type extension, bin, txt, etc. Okay. Put one file name, address. segment to load to, input 3, memory offset to load to. Okay. So that's assuming it all works. I don't know if it will. Let's just see what happens. Do we have an error? We don't have an error. Okay. That's good immediately. If I can type, that'd be better. So, well, we can see if loading a text file works first. It loads forever, so obviously not. That's not good. Loading a text file does not work. Does the other commands still work? CLS, okay. Okay, let's try loading a program like calculator. Just has a bunch of zeros, so I might be messing up somewhere with maybe the extra segment or the data segment. Somewhere in loading, because we're just getting that no matter what. We're just getting a bunch of zeros and like garbage data. Okay. So somewhere around there, that's not right, obviously. I'm assuming it tries to load it though and go to run programs. What would the issue be here? That should be correct. This could be it. ES has to be in kernel space. I wasn't doing this before. And this goes to ESDI, doesn't it? So that might be an issue. Unless I set move ES beforehand. Yeah, I don't know why that would be an issue. I'll try setting it here first though, just to make sure. Just to rule this out, I'll set that here to move it to kernel space first, ESDI. Don't think that's the issue though, but... No, it's not. Okay. Well, I don't know. Maybe we'll try 800 here. Nah, it doesn't do anything. Which I didn't think it would. It'd be the same either way. I'll move that back. Yeah. I don't need to do that. If there was an error, it should print out the error, so I don't think that's the issue. 0 if successful. Just get rid of that. Error, program did not load correctly. So if we got down here, I'm just going to print a T, if this will work. So we'll be able to tell. No, it's not erroring. I need to make again, but... So I can spell. No. Interesting. So it is going to run program. I'm assuming we're getting the extension all right. Okay, I found the issue. It is because within load file, well, I guess let me open it up here. All right. Within load file, when we go to check for the file name, we call the check file name function down here. This changes ES, the extra segment, to 0, and I never really change it back. So when I return, the comparison wasn't really correct. It was going to run program every time, but it was going to print the file every time. So just put a to do to see why it was doing that, and I found out why. So if you try to print out the bin file, it wasn't really working. It was loaded correctly though, so I did this here, added these lines, move extra segment, data segment back to kernel space. So 200H, move it into DS and ES. And then this is fine, and then this is fine. So that's all I really had to do now. Printing, well, let me show it works first. So now we can load the bin files as normal. So calculator goes to here. Again, still has a syntax error, but it'll print and stuff's right. 5 plus 3 is 8. Okay. Escape goes back, still leaves that. We can load the editor again. Let's try to load file table. That does load. Control R returns. Okay, everything works normally. The issue is if we try to load the text file here in the kernel, because we're not passing back the correct file size, or we're not passing back a file size at all. So it just leads to that, you know, that garbage. So is it print text file? Yeah. So I think file size here is not getting filled out. So this is maybe some huge number it's trying to load because it's just garbage in memory or something. So I'm going to take a cop out here. Change this later. And I'm just going to put 512 into CX. So I'll leave that there because I know what it was doing. But right now I'm going to assume text files are less than 1 sector. Change this later. Currently assuming text files are only 1 sector. Okay. So we'll just try that. So that should make it work. Yeah. Oh, well. Not really, actually. I mean, it only loaded 512, but it did not load the whole thing. So why is that? Interesting. It didn't really load it. Oh, BX. Yeah, I'm using BX for this. So I assume BX was 0, I guess, but whatever. I'm using ESBX. AH0E. I don't need to move 0E anymore either, because I'm not doing that. Calling print character. Yeah, I don't need 0E anymore. I don't really need to do X or. I don't think anything else calls this. Because I'm moving this into CX, so I don't need to do that either, I don't think. But since I'm using BX down here, I do need to XOR that. Using BX as offset for memory location. Below. Okay, let's see if that works. There we go, yeah. And we do get the invalid characters because it's, you know, it's not valid, but that looks right. Let's compare it to how it looks in the editor. Yeah, same thing pretty much, although that handles new lines, but yeah, so that's good. We got that out of the way. Can do shutdown. Okay, let me get rid of that dead code because I'm gonna feel so much better when we get rid of it. It's very cathartic. Getting rid of all this stuff. Isn't that nice? Oh, that's so good. That feels great. Oh, it feels great. Look, 724 lines. That's less than it was, right? And we got some more stuff down here. There we go. No more int 13. Nope, no more int 13. Not in the kernel, at least. So that's good. One other thing I still wanted to check. Yeah, so graphics test has an int. After I replace this disk loading and saving with the ATA ports, I'm going to go ahead and go to 32-bit mode, and until I set up interrupt descriptor table and service routines, we won't be able to really use these int functions anymore. So until after I go to 32-bit, I'm going to be doing a better graphics mode with Visa BIOS extensions. I won't be able to use int 10. And I'm going to redo the graphics test stuff when I get to that point that we have an actual probably 1080p screen. I have on the list to make graphics primitives that we can use later for visuals or games or maybe a windowing system eventually or something. Just, you know, lines, triangles, squares and stuff. The point I'm trying to get to right now is I'm going to get rid of this graphics test right here. We're not going to do anything. I'm either going to comment it out or just maybe, yeah, probably just get rid of it. We weren't doing really anything here anyway, so it'll just be another reboot right now. Fill this out later. I'll put a to-do here. Fill this out later after moving to a VBE graphics mode. Put examples of graphics primitives here, such as line drawing, do triangles, squares, other polygons, circles, etc. So I'll do this later. That's just to get int out of the kernel, so we should not have int anymore. int1 isn't found. I don't know what I just did. int0 should not be in here either. Okay. So no more interrupts in the kernel, so that's pretty good. That's pretty good. And just to make me feel better, let's test that stuff again. Okay, that loads. And we'll make sure the binary loads, yep. Okay, bootsector still loaded from that, interesting. So, turn is question mark, okay. So the only other place that we had int 13 outside of the bootsector in the file ops file was in the print file table file, right? Yes, so let's try and replace that. Alright, so we're using it on, in the print file table, okay, right here. We're loading the file table to memory, so I called it file table, right? That's what it's called. That's the name of it, is file table. So if I just hard code that, it would work. So I'm just probably gonna do that. So I can call load file to load it to the location of 1000. And then file name loop, I have to set it to 1000. So I'll do that, I think. This to memory. Okay, so we're gonna replace this with a call to load file. Hopefully we don't get it, but we'll see what happens. But it needs an address to a file name, which is not great. So we might have to make a variable for that. Just in here. So I'll do that. We'll do file table name just to have a variable for it. A storage space for it. 3, 4, 5, 6, 7, 8, 9. We'll end it with a null. Although, well, we shouldn't need that. We'll see if that works out. And I don't remember what I called it. Underscore name, yeah, okay. Segment I want to load it to, we can say, again, 0. And offset, we can use 1000. So load it to 1000. And assuming it loaded, well, we should be okay. Just put that there. This doesn't do anything. I don't know why I had that there. That didn't do anything. We're overriding AL and stuff here. ES is 100, that's fine. VX is 0, that's fine. Don't need to do that anymore. Shouldn't need that anymore. Okay, I'm assuming this will be alright. I'm not absolutely sure. Let's find out. Okay. As in print file table, which is the directory command. And that looks like it worked, so that's good. Reg, we'll go to editor load, and that works. Okay. I think we're alright there. Print file table. Okay. I'm going to copy that to the end of the line just to check it in grep. I think it's that. Yeah, only in the editor and the kernel. So yeah, I think we're good then. All right. I mean, that looked like it worked, right? So I think we're okay. The only place where this is included also have load file included. So we'll get rid of that. So that gets rid of any interrupts in this file. Pattern not found. Pattern not found. Cool. Okay. Okay, so it's only in the boot sector and it's only in file ops. So I'm going to mark the other refactor off my list for print file table. Okay, so I had the other day, it's under tests, right? OS dev, because I have a test folder. Yes, so I was messing with ATA ports, which is how I found that it actually worked, and we're good. So I have two files, ATA ports test ASM and ATA ports kernel ASM, which are just basic, just a really basic boot sector test. And I always forget autocomplete doesn't fill out the extension. So I don't need to use 16, but I included it there. It's a boot sector test, so org7c00. And you know, the boot sector padding, 512 bytes with the magic number. So, but the ATA ports I took from the OS Dev wiki page, which I'll show here in case I forgot or people don't have it. Okay, so I use this example, which theirs is in 64-bit. I'm using 16-bit, not doing all these flags and stuff pushing, but basically we're using the registers for ATA ports, which for ATA, protocol or standard or whatever you call it, I think ATA is advanced technology that IBM did. And then ATA was AT. AT, like the PC AT was advanced technology, I think is what it originally stood for, which I read on Wikipedia a while back. The XT, I don't know, extended maybe, but ATA was, I think, advanced technology adapter, if I remember right, but I could be wrong, so take that grain of salt. But there's basically like a data and a bus line or whatever, and they could be high or low. So there could only be, you know, originally like 2 drives. They called it a master and a slave drive. I guess nowadays it'd be like main and secondary or whatever they want to rename it to. But so the primary bus, data bus that controls this, there's IO ports. Port 1F0 is kind of the base. Through 1F7 for registers for ports that you can read and write to for ATA for the primary bus. The secondary is at 3F6 and 3F7, 170 to 177. But the primary drive that I'm going to be using is 1F0 to 1F7. So they put offset from the IO base. So 1F for the primary drive. Think about this. 1F0 is going to be a data register that you read and write data to. So we're going to read from. If we write data, we'll write data to this register. 1F1 is an error. You can read an error thing. Features, sector counts. We'll be using 1F0, we'll be using 1F2 to specify sector count. 1F3 for, what is this for? They label them better over here. Sector number. That's not the actual name, but 1F2 is the sector count. You send your sectors there. Port 1F3 is the sector number port. Or if you're using OBA, it's like low, mid, high. It's kind of offset within 3 up to 16-bit values. But if we're just using cylinder head sector addressing, we can just use this for the number of sectors we want to read. And then if we had, you know, high cylinder counts or sector numbers, whatever, we'd use 1F4 and 1F5 as well. I just send zeros to these for my example, but cylinder low and cylinder high. You also put that in if you have, you know, higher areas that you're reading to from the disk. And then we'll use 1F7, which is the command port. If you read from it, it's the status register. If you write to it, it's the command register, command port. And we're sending a 20. So I think there is, is it called a matrix? Yeah, command matrix page. I'm going to be using byte hex 20, hex 20, sending it to port 1F7, like they have here, for the read with retry command. So read sectors and keep retrying if it works. We can do read without retry, but the example and my example work with read sectors with retry, so we're going to go with that. For writing, all we have to do is instead of reading from port 1F7, we'll write to it, and we'll be using command 30 and hex to write sectors with retry. So reading and writing are pretty simple. That's how they had theirs as well. Write sectors, yeah. Hex 30 to the port instead. And they write with out. So they're using out string word to write, and they're using in string word to read. So in flat assembler, out string word transfers the source element to an output port addressed by DX. So source should be SI or ESI with any segment prefix. So I'll be using DSSI. Although if you specify it, then it should use that instead. But I'll be using repeat out string word to write, but right now just for loading for reading, I'll be using repeat in string word, which reads into DI from the port. So my example is pretty simple, 16-bit. I'm using 1F6 for the head and drive number port. I don't know if that was correctly labeled in this. Primary, secondary bus, 1F6, yeah, drive head register. So you kind of have to, it's both contained in one, it's using nibbles, so that's always fun. So the drive number, I'm just moving into, this doesn't matter for my example, for drive 180, it's not gonna matter, or even drive 2, but, because it's gonna be overwritten right here with this OR, but I'm just including it here to, you know, make more sense. But since I'm saying we're using hard disks, ATA, I guess it was IDE was the interface protocol for these ATA ports. So technically kind of trying to emulate an IDE drive instead of a floppy disk drive. But I'm using 80 here, which is what we've been using now for hard disk 1. You can AND it, so the second nibble, the 4 least significant bytes in AL are going to be the head number if you pass the head number. I haven't, I just have a drive number, so I'm assuming head number 0 for this example. I might have to change the head number in my actual OS code, I don't remember, so that might be fun. We might run into an issue there in a bit. But I'm using that, and then I'm ORing AL, like the OS dev example. I'm ORing it with A0 for the master drive, or if people don't like that, I could call it primary drive. I don't know, primary and secondary, they called it master and slave. I'll call it primary and secondary. So A0 primary drive is going to be in the high nibble for the head and drive port, and then we're going to write it out to DX, which we moved to 1F6. That's all I'm doing there. If you want to use the secondary drive, this will be B0 or 1011 in binary. A0 is 1010. Okay, so we write the head and drive number, how many sectors we want to read for this example. In this tiny test kernel, it's only 1 sector, so I'm moving a 1 to port 1F2 for the sector count. What sector do we want to start reading at, rather? This is the number of sectors we want to read. Sector number we want to start reading at, for this example, is sector 2, where I put the kernel. So 1F3. Then cylinder low and high, I'm not doing any high cylinder counts. We're only doing sector 2. And then the command port, I'm doing the hex 20, read with retry. So there's a couple ways you can test to make sure it's ready to be read. I'm assuming these work fine in QEMU. They did when I tested the other day. Not like the keyboard data port, which wasn't working, but this seemed to work okay. We're reading from 1F7, which makes it the status register. That's 8. So yeah, we're testing the 3rd bit pretty much. That'd be this in binary. So we're testing bit 3 if it's 0 based from the least significant to most significant. So testing if bit 3 is active, or if it's set. If it is set, it means the sector buffer requires servancy. So the hardware, the ATA ports or whatever, the microcontroller for the disk, whatever this is supposed to be affecting is still waiting to be ready pretty much to send data over, or well, in this case to read data from, since we're loading. So we're just waiting until it's ready by repeatedly testing that bit. And if it's ready, well, if it's not ready, we'll keep looping. If it is ready, we'll go on. So if I want to read it, I'm going to read into ESDI of 0 offset 1000. So here, linear address 1000 for this example. The number of words I want to read is 256 or 512 bytes. I just did 256. When I tried this with in-string byte, it did not work, but in-string word did work. So I tried this with 512 and in-string byte. It didn't work. I don't know why. I don't know. QEMU is weird, I guess. Doesn't work. But 256 words of 2 bytes each did work. Okay. And then 1F0 is the data port. So we're reading from this port with in-string word. We're reading from this port and we're reading into ESDI. So into memory location 0 offset 1000 or linear address 1000, reading from the port 1F0, 256 words. So that's 1 sector into memory location 1000. And then assuming the repeat went well, we're going to jump to our loaded sector, which for this case is, kernel example. 100 to set ES to there, and then we'll jump to it. Just to set up the extra and data segments in case you want to do data comparisons or anything. Okay, so the other file is just my tiny kernel that we loaded. I guess I made a change here. Yeah, because I did that. So the other file here is the kernel file. All I'm doing in the kernel is just writing hello world to screen. You know, I'm clearing the screen to blue by writing to video memory. And I'm writing a string here. So, oh, I also found I'm going to change to using this in the OS. I just haven't done it yet. But to get lengths of string variables and easier ways just to do this instead of having to spin magic numbers or hard coding things, you can do .len, define byte, and then an expression. So I'm using $ for this current, the current offset into this sort of address space here. So after memory, when the assembler gets to this point, after this point in memory, if we do $ string, it'll take the string offset here, which in memory starts, you know, with these bytes defined. So it'll take the position after this and it'll subtract in basically the length of the string. So passing it to .length, then we can use it as string.length. So it looks a little nicer. So I'll be using that in the OS if I remember going forward. That'll be some, you know, minor refactoring we can do to clean things up. But this just prints hello world to the screen. I've babbled on long enough, so I'll show that. I already had them here, but I'm just going to delete the bins. Just to show you that it does assemble. So ports test assembles, ports kernel assembles, although I think I have that in the make file, actually. Yeah, make file, I run FASM, put them into OS, and then I'm loading it. So how am I running it? I'm not sure I needed to do this, but this just helps me conceptualize it better, and I think maybe it'll work better. I don't know, but I'm setting IF for interface to IDE, just to ensure, hey, we're emulating an IDE interface for a hard disk. But we're doing IF IDE to emulate an IDE disk, so I can just run make and that'll work. And there we go, it runs hello ATA Ports world, using the ATA ports to load one sector. So I'm going to be doing that. And in the OS, I'm going to be changing probably the boot sector first, but I did want to show that that worked, and that's what I'm going to be basically trying to copy in the OS here. So, okay, back from my break and about half a beer in, so if this goes horribly wrong, or I don't get anything done, or I fall asleep in the next 2 hours, well, you'll know why. That's my excuse. I guess it's HDMI pass-through, kind of. I got the Camlink Elgato thing. I'm using that. I was using a capture card for the camera footage, so now I'm using the Camlink because it frees up a USB cable. So I'm not using the cable and an HDMI plugged into the PC. Now it's just the HDMI into the Camlink thing, which plugs into a USB port on there. So I'm hoping the quality is the same, if not slightly better. The colors may be a little bit different, depends on, you know, the encoding and everything it does. But I guess since it's made for this situation, I'm assuming it'll work better. So I don't know, but anyway, it frees up space in a cable on my desk. So if it looks a little bit different, that's why. But I'll get to this. I got the boot sector I was going to look at. I'm also going to open, it was like way back here. It was under my tests. Yeah, OS dev and ports test here. Yep, just because I forget what the ports are. So I'm going to put these ports into the boot sector, see if we can still boot up. I'm going to change this to use ATA ports. I'll change this simple. It'll still be simple, but you know, for sarcasm and comedic dry humor purposes, I'll put it within quotes. Uses ATA PIO ports. Read from disk into memory. Okay. Let's just save this off first. Let's put this first. DL contains the initial drive number on boot. Yep, okay. So we'll just go along with what our other example was using. I could even just copy them all over. That'd probably be easier, wouldn't it? Send head and drive number. All right. So this will be, I guess DL hasn't changed to this point, so I'll make this DL drive number, which should be ADH for these anyway. Head number, we don't have a head number, it's gonna be 0. At least starting off here for these things in the boot sector, it's gonna be 0, so we don't really have to worry about that, but I'll keep this here because it's more generic. We'll be, yep, assuming the primary drive, that should all be fine. 7, 8. I don't know why this is indented twice in this, but only once in like all my other files. I don't know why I did it like that. I could be annoying here. Do that. There we go. That's always nice. Just indent it over. Okay, yeah, I'm just gonna take all of this and do this. And that'll go under here. Put a big gap so I know where it's going, and we'll put it there. Sector count. We will read one sector. We'll start reading at sector 2 still, I believe. Isn't that what we're doing? No, we're starting reading at sector C. Sorry, never mind. This will be 0CH. Okay, memory address to read into. Yeah, will be 1000. One sector, 256 words, and we'll repeat reading into DI, into ESDI. Okay, that's okay because before we jump, we set the segments anyway. Okay, so that's all right. So don't need that. Any more of those? AL's number of sectors to read. All right. We'll do similar stuff though for the kernel. So I'm just going to copy all this for now, and then we'll change it slightly. Or I could I could abstract it into one area and then just jump to it or call it. But I'm not doing that right now. Sector count, I don't think if these aren't changing, I don't think I have to change them here. But I'll decide on that after this works, if it works. So, still gonna read, well, we're gonna read more than one sector. How big is the kernel now? A, so 10, okay. So number of sectors to read will be A, 0A. And start reading at sector D. Low and high should still be 0, that's fine. And we'll read it, do this stuff again. Loop will have to change. Put this here so I know where I'm at, otherwise it's confusing. All right. I'll call this kernel loop or K loop. I'll call it kernel loop. Otherwise it has the same name and we'll get an error for that, which we don't like those. Errors are bad. Kernel we will read into 200, yes. Get rid of that. Starting sector 2. Oh, starting sector will be 2 as well. Oh, I read the calculator, yeah. Well, this is what a half a beer will get you, right? Kernel is A in length, but the sector's at 2. I don't know why yeah. Sector's at 2, it says right there. That's why I had this open. 2. Dummy? Alright, that's okay. We want to read it into 200 like I'm moving here. So address 2000. We don't need to do that. This will be read sectors into 2000. Then reset segment registers for RAM. That doesn't really, I'll just word this better now. Set segment registers for kernel memory location. That makes a little more sense, I think. Set them all to 2000, which is where the kernel's loaded. Far jump to kernel. Never return, hopefully. Okay, so the only thing would be the drive number, case DL should not have changed, but so we're using it in a different place. I'll just move there. Since it's saved off, that should be alright. DL the drive, yeah. First one it might not have changed. This one, I don't think it would have changed, but I'll just do that anyway. That should be all we need to do. That's not too bad. It's not that much larger. Still, yeah, only a little bit over 100 lines. So that's not too bad. It still fits within 512 bytes. But nothing loads there, so that's good. That's interesting. I'll just call it set registers. I don't think I have to, but I'll just, I don't know. 2000 probably not. Let's see what happens if we XOR it. I don't see any errors. I can't type. I don't think SI will change anything. I mean, it is loading the kernel, or else we wouldn't have the screen cleared to blue. It's just after the screen is cleared, something is not right. I think sector count is correct. So I guess this word, yeah, I'm only reading one sector in down here. That's the issue. I'm only reading one. But you set it up by saying the number to read. So I think maybe this loads this much data like into the port, into the buffer. And then after it's loaded, you can read up, you can read all that data out. So I think I'm only reading, I am only reading one sector right now, but I think the other 9 sectors will still be in the buffer. So I just have to increase this to, a 10 sector amount of words, which will just be a 0 on the end because math is easy like that. For 10, 0A, H, sectors. Okay. Yeah, you have to actually read the data that you put on there. That's cool that they kind of separate that out. I didn't realize that till now. All right, was that the issue? Yeah, that was the issue. If you load up 10 sectors to read, well, you might want to read those 10 sectors, But I guess, if you want to buffer things or you want to be more space efficient, or if you're allocating extra space for things, then I guess, yeah, it makes sense to load up like more than you need and then use it as you need to use it. Like, load up 10 sectors and then go through the first couple, and then if you need more, then read in the next couple or something. So I can understand, I guess, why they did that. That's kind of cool. So directory no longer works though, so that's nice. Okay, I found my issues. They were kind of, little dumb issues, but I had to mess with things for a long time. So hopefully I go over what all I changed here. It's not that much, but in the file table, print file table, include file, I added 2 lines. I added this in case it wasn't there before, just to ensure we're passing the drive number, because that would cause issues if it wasn't being passed. So I added that. And the other one is at the bottom. I changed the name. It was, it was that. It was this, but I figure if we're checking for a full 10 length name in the check file name function in the file ops include file, I'm just going to pass the full, legitimate 10 character name here with the space instead of the 0, in case that might have caused an issue, but that was the only thing in there. The other thing, unfortunately, I had to change the boot sector bit, so I don't know how much I changed here, so I'll just, go over it like normal. But I know this was different. I think this was DL, which is not good because I'm moving this into DX, so DL would be F6, and that is not the right drive number, so that could be causing an issue, yeah, for the file table. I was having a lot of fun tracking that one down. Just a very easy overlook thing, but yeah, just I'm moving it into drive number up here, so this is up here. Just move drive number into there each and every time we need to use it. The rest is the same. Sector number 1, start reading at C, do this, cylinder low and higher 0, read with retry, we loop. So I did read on the OS Dev Wiki pages that you should have a 400 nanosecond delay after reading a full sector, after reading, specifically reading. A full sector, you should have a 400 nanosecond delay. I tried it with no ops, because there were no ops. I don't really know how much time that takes up though. So some other pages said that a standard way that people did this was by reading the alternate status register, which is a copy for the regular status register for these ATA ports. So the regular one, when you read from port 1F7, like here, I'm reading in a loop here from port 1F7, that's the status register, but there's also an alternate status register at port 3F6 in hex. That is a copy of 1F7, but it does not affect interrupts like flags or other things. It doesn't affect interrupts. So just to be safe, you can read from it, and apparently it takes about 100 nanoseconds to read from it, so do that 4 times, standard implementation. I don't know if that was greatly affecting my problems here, but I just added it to be more sort of standards compliant, right? So anyway, I added that after I read in a sector. Okay, so that's for the file table. The kernel I had to change a bit. It turns out things get a little wacky if you read more than a sector at a time. So I'm reading in one sector 10 times, or 9 if it's 0 based. Since we read in the first sector before I check against this number here, I made it 9. So we're going to be reading 10 sectors. Memory location 2000, moving that into DI, moving it up here. Again, I'm setting this stuff. I don't know if I have to set this again, but I'm keeping it here for now because it works. Sectors to read is still A for 10. Start at sector 2. 0 for cylinder low and high, read with retry 20. Okay. So I added a loop here, called it kernel loop. Reading in port 1F7 here till it's set. Then when it's ready to read, I'm reading one sector again, 256 words from 1F0 into DI, which is at 2000, because I set that above here. So after I do that, I'm doing, again, the 400 nanosecond delay by reading the alternate status register 4 times. So then, since I moved 9 into BL up here, to read 10 sectors, we already read 1, so 9 more would be 10. Comparing to 0. If it is 0, I'm jumping to the kernel, else I'm decrementing. So I'm going to decrement 9 to 0 to read 9 more sectors. So after that, since DX was changed here for the alternate status register, I'm changing DX back to 1F7 for the regular status register. And then jumping back to the loop to test again and then read the next. Because I read, you want to test, you want to give it time to reset its ready flags and everything, the port, or the microcontroller, whatever handles this. So I'm using 400 nanosecond delay, but then you want to go in a loop and test again before it's ready to read the next sector. So since you're telling it in the setup here, we're going to read 10 sectors, I guess you have to wait between each sector until it's ready again. So that's what this is doing. It's looping back, waiting until it's ready to read, then reading one sector, getting a delay to set some flags, and then going back and checking again. So that's all it's doing, 10 times. And then the sector, I'm doing the same thing. I forget if this looks slightly different or not, but moving the drive number back in because we need that for everything. Set up immediately. Because that's like the first thing we do in the kernel. Moving 200 to all these, setting up the stack, the mode, the video, so all this should be the same. But I just had to change this stuff again. It doesn't look like that much, but it took me way too much time, as is normal, right? Yeah, the stuff does work now. So I might try and experiment with making this a little bit less code. I don't know if I have to reset all these up again, between all these reads. I'm assuming I don't, so I might get rid of the drive number is not going to change, so maybe I'll get rid of this section. And the cylinder low and high aren't going to change, but I don't know if they reset because that info isn't documented. And maybe I need to read the actual specifications for this. I don't know. I'll try to look those up, I guess. ATA specs. They're probably really dry and boring. That is, I believe, all that I've changed, though, but I'll just show, make and make run. If I don't get stuck in the window, CWM. Okay, but this loads now. Directory loads, the file table loads, and we're getting it accurately. But I think that was due to the drive messing up at the start that I showed. I want to move the actual drive number in. But we can call stuff, assuming we can spell stuff, which we can't, it's me. Oh, actually, that's not found. Oh, that's good. Did I mess something up? I might have by going back into here, and then that makes it not work when I try to load things. But I should be able to load, yeah, the editor. So still, other bugs I need to work out, but that works. Okay, let's continue here. I just wanted to make sure right quick. The only place we have int 13h is in the file ops file. So we can try and work on replacing it in there for everything and then be done with this for now until I change it later. As is tradition, so. Alright, so what do we have? We have delete file, load file, rename, and save, right? So it's only 4 things. Okay. We'll try to work on delete file first. Let me just pull this up over here. Get the boot sector there so that I remember the ports and how it's laid out, and maybe we can just copy paste and it'll be good to go. We'll see. Probably won't need to reset the disk anymore. I'm just gonna comment that out for now. Disk, assuming it's one sector. Alright, I'll keep that to do, but I'll put it there instead. Alright, it's just this area then, right here. Okay. We'll put it all here. Put it all here. Of course, this is reading and not writing, so it will change slightly for writing, but I'll put this here first. Do need the delay. Well, we don't need the delay for reading. We do need a different delay for writing, though. I want these to be over 1 indentation level. Shift that over, there we go. Okay, so that drive's gonna be okay. Sector count, or we're gonna write 1 sector. We need to start writing at which one? I guess it's located at C, so it would be the same thing. Yeah, start. This will be writing instead of reading, though. Sector low and high, or cylinder low and high, that's fine. Command, we're going to be using 30. This will be write with retry. We don't need to read it into there, but we need to write it to there, right? Yes. So how did out string worked a little bit differently from in string? So I want to look that up. Here we go. Okay, out string transfers the source element to the output port in DX. Destination is DX. The source operand should be SI or ESI. So SI instead of DI. Then we're writing out to the thing. Okay. So instead of DI, we'll do SI. It'll be DS. SI. Memory address to this will be write sector from. We will want to do out, but according to the OS Dev Wiki page, I read a little bit last night, you don't want to do that. The equivalent of 28-bit LBA, logical block addressing, PIO, CHS is the same as this. We just don't use the cylinder low and high stuff pretty much, but, or at least not currently. Need to send write sectors, 30, write with retry to the command port. Do not use repeats. That's just what they say, so I won't use it. There must be a tiny delay between each output. Uint 16. Now I'm assuming for reading they said after transferring the last 16-bit of a PIO data block to the data IO port. So this is, I'm assuming, the sector. Like after the sector you give a 400 nanosecond delay, because that's what I'm doing. I'm assuming that's right, but for writing it says after each output Uint 16. I don't know if that means each word. Like after each word I really need to put a jump, or after each sector. So, because it seems like it would be very incredibly slow and bad performance for each word. And then we have to do a cache flush after each write command completes. So I don't really know. There must be a tiny delay. So if it says don't repeat and a delay between each word, so it must mean, yeah, each and every word needs about a +2 size delay. I guess that would go to a word size jump. It would be assembled, so it would just do nothing. But we do need to send a cache flush after each command completes. But does that mean after each word completes? We do a cache flush, or do we need to after like the whole sector completes? I don't know. We're learning today. We're learning that OS Dev Wiki does not have enough info. And if you bring up a question, they'll probably just tell you to read the docs. Which is fair. The cache flush, I don't know. I guess I'll send that after the whole sector, and then if it doesn't work, then I'll send that after each word. I need a freaking loop for this stuff. This would be well, I already have a loop, but I'll call it write loop. I don't know. So 256. I'll put that up here. 1F0 needs to be out. String word. Be write bytes from SI. I don't know if this uses DS, but I'll put it here. I'll put DS. DSSI into DX port. Okay, and then we need a delay after that. So it said jump $+2. Small delay after each word written. Port. And then I'll loop. Write loop. So we'll try this first. And then after that, by that I mean after the whole thing's done, like for this situation, this one sector's written all the words, then I'll send the command. Send cache flush command. After write command is finished. Yeah, we'll do that. So let's move AL E7 out DXAL. So we need to send it to the command port, which is 1F7. 1F7, there we go. Okay, well, we'll see if that works. So that way I don't need the int 13 ones. To start writing at head drive. Yeah, don't need this anymore. Jump not carry. Well, we're gonna assume it worked. Alright, blank file data. Well, I'm not doing anything here anyway, so yeah, I'll just get rid of that. Yeah, handle disk write error here. We'll put that there. There is a register to check for an error, I'm just not doing that. Check error ATA PIO register here. Well, let's just see if this part works first. This should change the file table, and then if it doesn't work, we'll try and fix it. So, undefined symbol. Oh yeah, it's called file drive num instead. Yep, duh. Okay. Yep, file drive num. My mistake. There we go. Alright, so now that I got this stuff working, let's go ahead and... Oh no, we're gonna delete the editor. Okay, I did not get a new line. But editor was deleted and replaced with free space. Okay, so that works. It did write, it wrote the sector, or else that wouldn't be changed, so... We know that works. That's good. That's good. We did not get a new line after that returned, though, but is that in the kernel, or is that in the other thing? It's delete file. Call delete file, compare to 0, sure, print new line when done. Yeah, it should print a new line when it's done. And it did not. It did return back, though. Maybe X and Y are not being updated correctly, I don't know. Oh, you know what, didn't I just mess with DS? I have to change that back. Yeah, so I'm glad I caught that. Glad I caught that. But this does work, so that's good. Get rid of that. But I think I did... I'm using DSSI for writing down here. Here, I need to change DS back. So we'll just do that. We'll push DS. Yeah, we'll push it first. Save DS. Then after we write from there, I'll pop it. After this is done. Yeah, pop ds. Restore original, I'll just do restore. Okay, we'll see if that works. Delete editor, edi. There we go, now we have a new line. Okay, cool. Alright, let's work on getting the other stuff changed. And to-dos that say change later that we'll never get to. Those are always the best. Need to make again to get the editor back. Alright, create a new file, create another file with O. There we go. Testing. So we have the test file. So if we read test file here, just from the shell, it'll put testing there. Okay, if we delete test file, it's still gonna be there. I was gonna try to load it, but show that it wasn't zeroed out, but we can't really do that because technically it doesn't really matter at this point, so never mind. I mean, we're not gonna be able to load free space. I don't think it'll let me do this. No, it's just, it's garbage because it's 0. It does load it though. It loads from a 0. Address 0, so that's kind of funny, but... Alright. Never mind, that was a bad detour, nothing happened, so... I was gonna try to load the file again to show that the data was not zeroed out on the disk, but... Can't do that because it's called free space, so never mind. But we will change it in here anyway, just to try and hope it works, so... We just won't have a good way of testing that it actually wrote the data here. We'll do it here. Let me get this stuff again. Loop, right loop, cache flush, and we'll even have ds there. I might also make... like a little subroutine for reading and writing so I don't paste the same stuff again and again. I probably could reduce duplication. Definitely could. How many sectors are we doing? File size? Yeah. So file size, number of sectors, starting sector to start writing at. Okay. File size. Sector to start writing at. This will be starting sector. Okay, low and high will be 0, we're gonna write. That's all good. But I need to go starting sector number of times this time. That's what I'll move into CX, so... Need to do some multiplying here. Let's, well, it's, okay. This is a bad way of doing this, but, you know, this is what I'm gonna do for now. For multiplying. Since starting sector is just a 1 byte, we'll move it into BL. I'll do imul, so put into CX, BX times 256. Okay. So CX equals number of words for one sector times number of sectors. Yep. Okay, data port writing, okay. There we go. So that's not bad. It'll write a bunch of data, but you know, that's life. And then we'll send that. That should be okay. Probably will not be writing from 1000, will we? No. And we're storing DS, so don't want to do that. Track number, head number, drive number. Oh, ESBX, file data memory location. Where's ESBX set up? Up here, right, nulls. ES is 800, okay. And DI is 0 because we wrote all that. So ES is 800 up here. So DS will do, I'm XORing BX. Yeah, so it's 8,000. So we can do ES0 and SI 8,000, that'd be equivalent. So write sectors from the 8,000. Anything else I need to do? This is assuming it worked. We have jump not carry, but I'm not checking. Again, I'm not checking, unfortunately. To do check error register here. Okay. We won't really be able to tell if that worked or not, though. You know. We will be able to tell. Actually, yeah, we can tell if we load the file table. Well, no, we can't. Yeah, we can. Okay, yeah. So if we delete the file table, then directory, this command should no longer work. So let's test that. Right? Well, it should have written the bad data to disk, and it did not. Unless I don't reload the file table. Well, editor was not found. Ooh, yeah, editor was not found. So nothing is going to be found anymore. Because we did delete the file table. It just doesn't show up correctly in the editor thing. Can run commands though. Yeah, there we go. So if we reboot, see, we don't see it there because we deleted the file table. So it does remove the data. Okay. Just my way of checking that. I don't know how many sectors, if it removes all the sectors, because that's only a one sector example. But it did delete, so for now I'm going to tentatively say it works. And just get rid of this commented out stuff. Let me see. If this goes too much over on the sector count, then I'll consider it. But right now I'm not going to worry about that. Just open this here. It's loading file. Loading files will be using reading, not writing. I'll open the boot sector there. Alright, reset disk I'm not going to worry about. We're assuming it's going to be successful. Reading that, tracking sector, okay. We might want to keep that actually. But here we need to change. Head and drive number. So I do need to check the error register, because we do this every time. Let's call this a jump. Jump load. Okay, let's put it here. This one has multiple sectors. We'll do this one. We'll do this one. We'll call it different stuff though. Instead of jumping kernel loop, it'll be different. But it's a lot of lines. Oh well. Bam. Shift down. Move that over. Okay. So CL has the sector number. Where do we use CL? Number of sectors to read. This will be CL from above. Or I can move it into file size. Probably be better here. Then I can make this kind of generic. That there. Use file size instead. And sector to start reading now, we want to be starting sector, yes. There we go. CL into file size. Well, you can move it into BL as well. Or replace this. It'll be this many sectors. File. Be reading file size, number of sectors. Yeah, okay. Where do we want to read them into? That's a good question. SDI plus 15. Why is that down there? Now we have to remember what BX was at first. FS is going to hold the segment to load to. So that will make into DS then. FS, okay. I don't think I can do this, but we'll try that. $2,000 will be different. I'm confused though. I put this here. I got this originally. Oh, is this a sector number to load to? Is that what that is? But I have sector number to start reading at here. Oh, and then this gets the correct one after. Oh, okay. Okay. So that's actually the starting sector after this stuff. Speed ports. Okay. So this is like the passed in. Well, this is the file table starting sector, but to get the actual one for the tracks and everything, because there's 18 sectors per track, in the file table it can be over 18 or different. So I'm actually getting the right one after this. So that's the actual starting sector. So the file size is ESDI plus 15 down here. I'm going to copy that. And move that into file size. There we go. And FS, I did move. We're moving that to ES. Okay. Okay, we're doing that. So I'm reading BL though. So BL needs to be the file size as well. I think I changed that. Oh, here we go. File size. There we go. All right, DI we need to change. Memory address to read into. That is going to be different. So that we're putting into the offset. So this is in BX right up here. And we're assuming originally when I was reading, I was assuming that was already set. After this point it was here. So before we mess with BL, I'll move that. Yeah, into DI, BX, okay. Memory address, memory offset to read sectors into. Although that's not very clear, but we move it up here. First parm off stack, memory offset address. So what I will do, copy that. I don't use BX until this point, right? I don't think so. No, I don't. Okay. Let's put that here. Offset memory address. And then we'll just move that into DI. There we go. We can do that. File size, number of sectors, head and drive, file size, starting sector, okay. Cylinder low high, read with retry. So I'm not going to call this kernel loop though, I'll just call it the loop if I can. Just call it loop. Or underscore loop, no, just loop. Don't have to do that, then we're just gonna leave. Okay, so let's assume that that works, maybe. Invalid size, yep, can't do that. I'll move ES into FS. Well, I don't even know why I tried to do that. I wanted to move FS into ES, but I don't think I can do that. Right? Yeah, it doesn't like that. Okay. There we go. To press enter first. Okay, we'll move that into... It is FS, right? Yeah. Second parm. Well, we can move off the stack into FS. So who's to say we can't do this and move it into ES for ESDI? Who's to say we can't do that? Segment memory address to read into. There we go. There we go. Then ESDI will be set. Okay. Define drive num. Of course. Did I put it here? No. It's down here somewhere. There it is. Jump to kernel is not. Yep, that's true. Oh yeah, what do we want to do after this? This kernel's not there anymore. Load function epilogue, I guess. Yeah, or else it'll go to kernel loop, which doesn't exist. It'll just be loop. I guess. Oh yeah, I was unsure if the local labels could be used there. That's why I did that. It's probably okay. I guess I'll rename this. This will be load wait. Load next sector. We'll call it that. It is a loop though, but didn't save it right. Okay, I'll just retype it. That's fine. Load next sector. So instead of jump to kernel, we'll go to load function epilogue. That's what we'll do. Okay. Unless there is an error. So I don't know if there was though. But we don't need that. I do want to check the error register. We'll do that there. So this stuff is not going to be called. Okay. There we go. Let's see if we can load something. Probably not. Because that didn't load at all. Can I load something right off the bat? Probably not. No. Okay. That's just any, well, print reg will work. But dir doesn't. Okay. Oh, what did I F up other than everything? Push FS, push SI. Set the file type, reset disk. Start reading at the starting sector. We don't want to do that yet, because we want to do this first. Oh, we want to do minus, yeah. So file size will be the number we want to read, but since we're reading one by default, and then I'm comparing for the file table, for example, that takes up one sector. So when we get down here, we're going to read in a sector. And then we're going to compare BL, but BL will be 1 for one sector. It's 1 is not 0, so it's going to go decrement and load another one. But there is no other one. And it's for these ATA ports, if you're trying to load like one sector too many than you specified, it just hangs. So I had fun with that the other day. I did not show it, but that was fun. So we'll do, I need to do -1, so decrement BL. All right, I'll do that. We'll just do decrement. The actual size -1. And there we go. See, it does work. So you're saying, you know, load 0 sectors, but not really. You're actually loading 1. So this should load the editor then, right? Okay, well that loads, that's good. Let's go into here, file table. That all looks okay. Let's try to make a test file. The reason I don't make test binary files is not because I don't want to, it's because typing the text is faster. The test file 11. And it's a bunch of garbage. Size in sectors is 1. Starting sector is 1B. That's interesting. And then directory does not load. Oh, okay. So I might have some issues here. Let's see if we reboot. Let's see if we try to load it now. No. We just have issues, but that still loads. Okay. Yeah, it really doesn't like that. Interesting. That could be from saving though, because I didn't change saving yet. But other stuff did appear to be loading. It's in disk, not print. I do push bx, fs, and si. And I do pop those back. Si, dx, fs, bx. Don't do that. I guess I'll put it there anyway because it's in the thing, but sure, whatever. It's weird. Although I don't know if that would be causing. That probably was not the issue, but let's just find out. Yeah, well, that's gonna be wrong. Not gonna be wrong, I just can't type it right. Yeah, doesn't work. Okay. I think it's because I changed ES here. I don't think DI matters at this point because we're not putting it back. So I'm gonna, I guess, reset ES and DI. Let's do that. Push ES, push DI. And we don't use it inside here. We don't need it. We need it down here though. Push ES, push DI, pop ES. Okay. I did that correctly in delete, right? I'm just using DS in there though. Okay, does that F anything up? Not so far. Test. This is a test. I need to prevent typing into the prompt because I do a backspace and it just messes everything up to start off the bat. I know, it really doesn't like whatever I'm doing here. I don't know what garbage it's trying to put in there. Zero is the memory segment, 8000 is the offset. The segment should be an ES, that should be 0. DI should be the offset, which should be 8000, should be 8000. Offset is +4, segment is +6. Yeah, so that should be okay. Yeah, I don't know why that's doing that. It's not loading correctly anymore. I'm passing 8,000, but it's not loading correctly. I think that's a ESDI. Yeah, I'm not sure. I'm gonna delete this anyway. Otherwise, handle error here. We do need to handle the error, but I'm gonna delete that stuff. Maybe I need to reset the disk. I don't think so though. Okay, we're back. I got my brain juice. Brain juice, otherwise known as black bitter bean juice. I came to the conclusion that the load file function must be working, or else when we initially load the file table or load in the editor or whatever to save a file to begin with, that's using load file. So I know load file has to be working, otherwise we would not be able to use the editor. And we would not be able to load anything in here to begin with. Even though I typed it in wrong, it still worked. But you know, like I wouldn't be able to do that if it didn't work. So I wouldn't be able to load stuff into here if it didn't work. So it has to be working. So I'm going to try and change save file and see if it changes anything, or if it still breaks, and then go from there. And then when save file works, we'll get rename, and then we'll be done with this. But let's see if we can change up save file here. Just put it in 2 places to remember stuff that's passed in and whatnot. Okay, address, new file, found file, reset the disk. I'm not gonna do that. Maybe I need to be resetting the disk. That's messing up. I don't know. I'm not doing that. Don't even worry about it. But assuming we have the file, we did call check file name. So we'll be able to look for it. Last save sector, that's good. Last save sector and file size, that's good. Write the changed file table to disk, okay. This stuff will be changed. Write the changed stuff to disk. Well, we did that with delete, right? That was before save. We did that with delete. Just the file table. Should be up here. Copy all this. Copy all of that. I'll put it below here. Put it below there. Okay. So file drive num, we're moving in. I'm saving off BX before changing, but I don't think I'll need to do that. I'm just doing, C for the sector number. We're just doing 1 for the number of sectors to read, or write in this case. SPX will be 1,000. I got that down. DSSI. And the head number, we're doing 0. Track number. Not worrying about it. That should be alright for writing the file table. Yeah, I'll keep that there. File data. And that's it. Okay, so that's not bad. Not too bad. All right, blank data. The disk write, we'll put it down here. Copy this. Copy the loop, the big loops. Right. File data to disk. Okay. Should still be the same drive number. So sector count, we should have the file size. Should have it. Not worried about the head number. Not worried about drive number. Save BX. ESBX is the memory location. So we need starting sector. Is that saved up here? Start writing at last saved sector. We get it in CL right here. I'll move that in. Starting sector. Give them the same name so that later we can abstract it, make it generic. So that should be okay. File size should be set. That should be all we need. Should be all we need to do. We're writing in the loop. It's not necessarily 8,000. Why am I doing ESSI? Why am I doing that? Maybe that's messed up. If I'm doing out is from SI, but it's a DS. This should be DS. DSSI is writing. Did I do that with delete? Because that's not good if so. Out string word. That's DSSI. That's DS. That's DS now. It should be DS if we're doing out. Maybe that was the issue with deleting, but I don't think that would be right. I don't know. I'm glad I changed that though. Let's remember where these are at. For the parms, memory location to save data from. So that's what we want to put into this stuff. So instead of AX, this will be FS, so BP plus 6. Memory segment to save data from. And then this will be BP plus 4. Memory offset. Memory offset to save data from. Okay. That should be alright, right? Hopefully. Maybe not. I think that'll be alright, but you know, every time I say that, everything ends up broken and not working, so. And now it's too big, yeah. Now the kernel's a bit too big. Because of all that. That's okay. That's alright. Well, I'll try to reduce the size later, but that's okay. So 512, so this will be 632. So it's 11 sectors. Yeah. 11 sectors in length. It's a big boy. Okay, so kernel is B in size now, which means, well, the file table is going to have to change. To D, 2 plus 11 is 13, which is D. This will be E, and this will be 11. That should be right. Alright, which means bootsec needs to change. File table's at D now. And the kernel is B number of sectors. And go back to here, so 0CH. Start writing a D, it's still one sector though. Rename we do need to change. So the editor did not increase though, just the kernel, so that's interesting. Just interesting. I didn't have to make that again. Oh well. Okay, so I did not change the file table somewhere. That's good. Nice. Where did I not change that? I want to read one sector from D. I'm going to read it into 1000. Oh, BL has to be 10. Yep. Well, 11 minus 1, 10. Yeah, that is true. Hey, there we go. 11B. Yep. Okay, that looks correct. Okay, so can I load text file? I can. Can I load a binary file? I can. Can I load a text file within this binary file? Yes. So let's create test or tease. Save file error. Okay. I got an error on saving. Let's try to return. It did write it to the file table. At 1C. So that's 17 plus 11. That'd be 28. And 1C would be 16 plus 12, which is 28. So that's correct. Okay. But can we... Okay, and we can read it. But maybe mixing int 13h with these ATA ports is not a good idea. Since loading was working but saving wasn't, and now saving appears to be working. I know I got the error, but that's because I didn't change that code correctly, I believe, and that is there. Okay. I think we're okay. I think. Till it all breaks. Or somebody actually uses this and tells me that, hey, it's all broken and it doesn't work on my machine. And I'm like, well, it works on mine, you know. I do that at work a lot anyway. But then I fix it for them because they look at you like you're stupid. Good old end users. Let's go to save file. Oh, let me change this too. I don't like this being like this. Let's do like I have the other ones. Input 1, file name. This will be address. Yeah. Right? File name goes to SI. I move it, yeah, address. Put 2 be file type. File size and hex sectors. Memory segment to save from. Yeah. Memory segment to save from. Memory offset to save from. Where do I have the error? So I'm writing and the to-dos that I need to eventually do actually, but not resetting anymore. Don't need to do that. Don't need that stuff. Oh, I don't need that there. Obviously, yeah, file name's going in there. Move 10 bytes of name. File type. There we go. Directory entry others. Size. Write the change. File table to disk. Okay. That's a 0. Oh, moving an error into there. Yeah. Of course. Let's jump to... That's why it errors, because I put an error there. We'll jump to there. But I'll have to handle the errors later anyway, so... Yeah, that's alright. Okay. Okay, let's just do that again to make sure, since I changed that. Create testing file here. Let's make sure we can load it from the shell in the kernel. Testing file here. All right. I did not get an error when I saved it from the editor. And I can load that. Okay, cool. Cool beans. So let's change rename. Does rename work currently? Oh, that doesn't. Oh, that's... Why is that like that? So if I load it again, nothing works. Well, that's good. That's always a good sign. Shut it down, run make run. No, that is okay. I save a file, and then it doesn't go back. That's interesting. Wonder why that would be. That's not good. I want it to work after you save something and leave, you know? That's the first thing we get in save file is, yeah, right here, file size. Okay, so file data should be okay. Only writing one though. Because I'm moving it down there. But CL will be the starting sector, yes. Okay, this doesn't need to be starting sector. This needs to be file size. That's what that needs to be. Yeah, because if it's down there as like 1B or 1C, that's going to be a buttload of data to write, probably overriding stuff and killing everything. So yeah, don't do that. Get the actual file size, which in this case is probably one sector. Yeah, that might have been what was wrong there. I would assume that's a great deal what was wrong there. And backspace, you know, just quit. Just don't even. If we don't save, that breaks. That's nice. All right, save a file. Go back. We have the file there. It says it's starting at sector 1C. The size is 1. Are we starting in the right one when we save it? I don't know. I mean, this works here, but I might have overwritten the boot sector or something, so... Can it reboot? It can't reboot. That's good. Oh, that's great. Okay. Just break everything, dude. That's all you need to do. I don't need to do this. I'm setting DS and SI, yes. Save from. Segment and offset. Which should be 1000 and 0 if it's from the editor. For address 10,000, these should be 1000 and 0. I don't need to XOR AX there. I will save DS though. And SI, but that's restored later. SI CX FSBX. Yeah, those are correct. Okay, maybe I need to start taking more breaks because I always come back and figure out what the issue is within a short amount of time, so that's always good. Or sleeping. Sleeping works wonders for that. But I am in the load file part of the fileops.inc file. I just opened it on the side so that I knew which part I was in. Load file. I put new lines. Yeah, so I don't need this other stuff like up here, but I'm going to get rid of this. I'll get rid of that in a second. So the reason it was failing to load after reboots is because I was still using this old code here for getting the track and sector numbers. Now this is only used for basically for floppy disk or early hard drives, I guess, that were limited to 18 sectors per track. Now this CHS or 28-bit LBA PIO port usage technically does not have that limitation at the moment, as far as I can tell. So I don't need to do that. It was working and saving the files, but it was kind of overwriting the files to early sectors on the disk because I was, taking it mod 18 pretty much. So modulo 18 and then taking that in there, which made, late files very early, and it was overriding the boot sector and other stuff, and that, that ended up not working on reboots and stuff. So we just take that out, or I changed here to re-get the sector number, moving it into starting sector. So instead of changing it mod 18, again, I'll comment this out now because I don't need to do that. Starting sector is okay. Number of sectors to read, we're just taking the last value. We're not getting the new one. And that ended up working. Well, load file was good before, but save file was not. But I did add that to load file. So let me get rid of that. So new. Down here. All right. So this is under save file though. Yeah, under save file. This new here, I'm moving last saved sector into AL because that is what this value equals before we're modding at 18 to get, the 18 sector per track limitation. I'm moving CL into starting sector here, but I'm not using starting sector down here, so I'm not going to worry about that. We can use last saved sector. That's the value we need to get because that's what we're getting up here. When we get the last thing in the file table, we get where that starts at, and we're adding the size, and that's where we're starting at now. Yeah, I'm getting the starting sector and the file size. That equals last save sector. Okay. I don't really need this stuff here. Starting sector I'm not going to use. This stuff I'm not going to use. I'm going to remove this in a second, but comment that out for now. But that ensures that the stuff works if it doesn't break right now. Yeah, we'll move this over. I'll show you this still loads. If we go to the editor and save something, test or TST. All right, saved it. It's there. We can load it, same as before. We can load it in the editor even. And it loads there. Go back. But we can do reboot now. And it'll load back again. We can do shutdown. And, well, I didn't need to make it again. Now I gotta do all that. All right. Okay, shutdown. If I spell it correctly, make run, and everything works and it pops up again. Okay. So that was it. Just had to, we don't have to deal with the 18 sector per track limitation using these ATA ports. At least at the moment we don't. Maybe there's another limitation for sector sizes that I haven't run into yet. I know sector goes from 0 to 63, so I think after 63 I'll have to change it. But until we reach that point, I don't. So, I guess I'll cross that when I reach it. But we got that changed, so that's good. I do want to remove int 16 or int 13 from rename, and that's the last place. So I still have new right there. Get rid of that. And I'm going to get rid of these comments. Shorten the code a little bit. It was also under load file. Yeah, let's get rid of these. Cool. Okay. So rename over here. We need to change this as well, but rename's pretty short. It is just writing the file table again. So let me copy the file table size, or the file table section here. And we'll put it under rename. Write changed, file table data to disk. Yes, I'll put it underneath here. And we'll shift that over so it lines up. All right. We'll do this. Again, we need to check the errors, but I don't really feel like doing that today because I've dealt with enough errors today. Bad coding, but this isn't production stuff, so it's okay. This will end on the rename function epilogue. All right. We'll only be writing one thing anyway. Does push and pop the S down there. It is 1 at D. Where's the... yeah, because file table's at section D now. File drive number, that should be fine. Track number, sector, we got that. Head drive, don't deal with, don't need that or that. And don't need to reset the disk. Is that all we need to do? I don't know. I'm hoping. We'll find out. We'll see what breaks. Is rename okay? Rename editor to text edit. Oh, it's text edit. That's good. Okay, now let's try loading that. Hey, it loads. That's good. Spelled that wrong. It doesn't matter. Okay. Let's make test file. It's there. Rename test file 1 to test. That's renamed. Rename calculator to math. Okay, so we seem to be good, but math does not work. So that's interesting. Does text edit still work? It does not. What happens if we reboot? And then run math. That works. So there's still some issues sometimes, but a reboot fixes it, it seems. And test goes back there. So that was not correct. Right? TEST. That's a text file, but that loads the editor, so that's not correct. That is definitely not correct. And that doesn't work, because I needed a bunch of spaces. Interesting. Got some weird stuff here. Text edit, does that load? So that loads there, but TEST also does. I'm assuming because they both start with T. That's what I'm assuming. So do we need a unique thing there? So let's rename test to R test. Okay, now let's try to load R test. And that's not good, so let's not do that. Okay, that works from here. Text edit goes here, so I think because they're both started with a T, it was like broken. Or it takes the first thing that starts with a T. So that's when I'm loading a file. I need to change how we check the file names and stuff, I guess. That's not absolutely correct. So rename rtest to tst. So if I type tst, it's going to load nothing. Found but not loaded. But if I reboot, that does work. TST loads the editor. So yeah, we got some bugs here. Okay. Not the best. And that does that because it's loading the editor. Okay. So that's on. Got some issues there. Or things are not being updated. I don't know. It's a bit jank. It's a bit janky to be quite honest. Rename file. It works better when you can spell. We have the length and the new length. The first file name, the new G. I mean, it does rename it and it does write the change name. So I think rename is fine. It's just a little iffy. I'll get rid of that. Saves it with all spaces. All right, change data. It is in 1000. Should be in 1000. It is. Yeah, 1 sector, 0D for 13. Push DS, DS0, SI 1000. Doing that, writing it, sending, pop. SI, CX, and BX. What we're doing, SI, CX, BX. Yeah, I don't know why it's being weird sometimes. I'll probably try and look at, if I remember, after I sleep tonight, I'll try to look into that. But my main purpose, even though it works janky, my main purpose was to replace int 13, which I did. So but the next episode could be bug fixes, depending how my research goes, off hours. I don't know. You know what? Are there other ints? Are there other like ints mentions even in comments? Because I want to get rid of those before I go on. Yeah, whatever. I don't know what this freaking build thing is. I copied it somewhere. So bootsector has mentions of int 10. It does use int 10. That's okay if it's in the bootsector. Reset graphics screen. We're not even using that anymore. I'll show you. Reset GR. Look, we're not even, oh, it's included in the kernel, but we're going to remove it because we're not using it. That'll be my order of business. Source. There we go. Yeah, we're not using it, so. Get it out of here. Remove include screen. There we go. These are my files. Does build show up in here? Build, I have a single quote file. I should have just used tree. But it doesn't even show up. Oh yeah, it does. What is what is that? Is there do I have a stat command? Can I do stat on there? No. Can I do stat on like what is this file? Let's try to do vim on it. Delete file.inc. Oh, it's this. Why is this here? Whatever. Remove it. There we go. We're good. We're good. We're good. No need to worry about it. We got rid of it. It's gone. Okay, cool. So that's going to be in the repo until I get rid of it, so that's nice. Git add this. All added. Remove unused file. And erroneous. That's a word. That's a $10 word. Put it in your wallet, your dictionary. Single quote file and build directory. In case it's there for people. It's removed now, so. And there we go. And we're just gonna push that up. Okay. So we're good. We got rid of ints. And is there any... I don't think I used any single digit int numbers, right? Or something that starts with a 0. I don't think I did. I haven't. Okay, so ints are gone. So, okay, we remove int 13. We're good. Next order of business will be to move to 32-bit mode. I'm going to make a global descriptor table, put in the boot sector. If it's too big for the boot sector, I'll try to refactor a little bit. If the boot sector is still too big for one sector, then I will make a second stage boot sector bootloader that'll call to load everything else, and that'll be fun if we need to do that. But I'll put in a global descriptor table, just a basic one, not an interrupt descriptor table yet. That'll be coming eventually. But the GDT, and we'll move to 32-bit mode. And I do have tests from doing things. Is it tests? No, it's in OS. I had tests a while back for doing just everything in C, which you can do. I messed with like a linker, very basic linker script. It's very small. Bootsector.c. So I put everything, in assembly in a C file. That's the only way I could generate 16-bit assembly with this and with, linker commands in the make file that I have here. But global descriptor table is pretty simple, but I'll go over this on the next one, right? I'll code it up for realsies. But this is also in freaking GCC AS, which is vomit-inducing, even though I made it Intel syntax. But we have, it's pretty short. You define a table and then how long it is, and this is a very, very basic one, which has like nothing in it. And then we load it with the command, we set the bit, and then we're in 32-bit and we can run to the kernel and it's all good. So hopefully it won't be that bad. We'll see. Probably will be with how I mess things up, but that's okay. but we'll do that next video for this. When I get to it, will be Global Descriptor Table in the boot sector. If I need to, then a second stage bootloader. And we'll go to 32-bit, and then probably the majority after that will be fixing whatever broke in 32-bit mode, since segment addressing will work differently. It's simpler in a way. We don't have to deal with right now, if you move a number into a segment register, it's implicitly multiplied by 16. So you move 100H into the data segment, then the data segment is actually pointing to 1000H because it's fancy in real mode. It's special like that. So after 32-bit mode, it will just point to 100. Or well, I'll probably set DS to just point to wherever in the global descriptor table. I'll point them all to like 0 or whatever, so it can just be kind of flat file-ish or flat memory model as much as I can, and then make things simpler. And then we can use 32-bit registers, so I'll have to mess with that probably. So anything involving segments we'll probably have to change, or at least look at. So that'll be fun, but we don't have a huge project right now. So I'll work on 32-bit in the next one. If we get that working, then after that I'll go to piece of BIOS extensions, get a graphics mode, and then if we need to fix other things from that, such as printing, we'll do it then. So that'll be fun. Thank you for watching. I really do appreciate it. If you got this far, or you just skipped to the end for some reason, you're a good person. I trust. But yeah, thank you. I do appreciate it. You all are wonderful people, and I'll see you on the next one.